Well, hello. This week coming up, we've got kind of a big idea. The idea of solving really big equations. But in order to do that, we have to kind of piece together a couple of different ideas. And one of the ideas we have to bring in is the idea of division. So in this video, I want to kind of review with you just sort of the basic division process. And if you feel like you've seen a lot of this before, feel free to kind of skip ahead during the video. I'm pretty sure though towards the end you'll see something that's one or two things that are brand new. So here we go. So let's kind of review the division process that we probably first were introduced to back in grade school. I don't know, probably sometime around maybe third grade, fourth grade. We started doing division, and sometimes division was easy, sometimes division was pretty difficult. So we'll kind of start with this example. I want to divide 15 into 3,126. I'd like to see how many times it goes in. And so the first type of division, we call this long division, where you're kind of looking at 15, and you're not looking at the whole thing, but you're kind of looking at 31, and you say, well, 15 goes into 31 two times, and then I do 2 times 15 would be 30, and then I subtract that from 31, and I'm left with a remainder of 1, and then I bring down the next number, which is 2, and I go, well 15 does not go into 12, so I put down a 0 right there, and so 0 times 15 is of course 0. And take it away, and so you're still left with 12, and then you drop down the next number, which is the 6. Now some students, you probably just drop down the 6 one step early, and that's fine. I'm just doing this to emphasize why the 0 is going there. And so now 15 goes into 126. Okay, now that's a little challenging. I think, let's see, 8 times 15 is 80, and 40, 120. So I'm going to go with 8. Okay. And so 8 times 15, as I said, is 120. And then you subtract that from the 126, and you're left with 6. And 15 does not go into 6. And at some point, you probably learn to add zeros or decimals, but we're not going to do that today. That really won't be needed here. What we would do is we'd say, okay, well, sometimes we wrote this down as, well, the answer is 208 remainder 6. That's how you probably did it when you were first learning how to do division. And later on, you then started to write it as a mixed number and say, well, this is really, the quotient is 208 and 6/15, which of course you could reduce to 208, and then let's see, divide a 3 out from each one. We're looking at 2/5. And like I say, you could also do this in decimals, but initially that's kind of how division worked. Okay, with the remainder expression and then the sort of the mixed number answer. We wanted to get stuff a little more precise. So that's called long division, and it can be pretty long and take up some time. So there's another thing called short division, which goes a little quicker. However, you've got to keep things in your head. And the way it works, in case you don't recall, 15 goes into 30 twice, and you're thinking, well, 2 times 15 is 30. 31 take away 30 leaves me with a 1, so I put my remainder here. And now 15 does not go into 12, so I put 0. And then I think 126, and 15 goes into 126 8 times, and that's 120, taken off of 126, and once again I get my remainder of 6. So it's really the same idea, except now you're kind of carrying remainders in your head and sort of jotting them down up along here. And this, of course, would be the same answers we have up above. So we have long division, and we have, sort of short division, which is kind of the faster way, involving you to do a little keeping some things in your head. So why am I bringing this up? Well, when you got into high school, you probably moved into a problem like this, which is we call polynomial division. Is how do you divide one polynomial. Usually we use very simple binomials and try to put it into a higher degree polynomial. Can we do that division? Well, the answer is yes, and we're going to kind of use the same thought process that we used up here, except we have to be a little more careful about how we do it. So let's kind of walk through that process together. And again, if you're really comfortable with this, you might want to just fast forward or skip ahead. So with this, you have to really kind of think about the sort of the leading term, which would be the x. And really you're asking yourself, okay, how many times does x go into each of these things? The -5 is kind of along for the ride. So here you'll see what I mean. So I'm thinking, well, x times what gives me 2x to the third? X times something gives me 2x to the third. And I say, well, 2x squared, that should work. So 2x squared times x gives me 2x to the third. So I'm trying to match that term. However, 2x squared also has to get multiplied by the -5. And so we have minus 10x squared. And so then the question, well, what do I do with this? And if you go back and you think about what we did earlier, okay, well, when I did 2 times 15, I got 30. So then I have to take it away from the top. So I'm always going to be subtracting or removing it from the starting value. So I'm going to remove this, and you got to be careful. So if I'm taking this away, this becomes a negative, this becomes a positive, and then I combine them. These cancel, and that was the whole purpose. And then what my leftover or remainder is 7x squared. And then as I've done with numbers, I'm going to bring down the 4x. And if you want to bring down the 12 too, that's fine. There's really no harm in just bringing everything down. With numbers, you got to be a little more careful, but with polynomials, just bring everything down. And so then you say, well, okay, x times what gives me 7x squared? And you're thinking, well, okay, 7x. If I go plus 7x, 7x times x, 7x squared. But then I also have to do 7x times the -5, which gives me negative 35x. It's very important when you work with polynomials, you got to keep all the like terms aligned. Otherwise, you're going to be combining non-like terms, which doesn't make any sense. Okay, so we've got this, and so now our next idea is, well, let's take these things away. So I'm going to turn that into a minus, make this a plus, and I'll combine. These cancel out, and that was by design. And I'm left over with 39x plus a 12. And so once again I ask, well, x times what gives me that 39x? And well, that's pretty easy, 39. So 39 times x is 39x. And then I got to do 39 times 5. Okay, let's see. That might be a calculator, but I can maybe do this in my head. 150 and 45, 195. Double check that. 150, yeah, negative 195. And so once again, I subtract this. Okay, so this becomes a negative, this becomes positive. And now I'll put it all together. These cancel. And then I'm left with 207, okay? And that would be the remainder, because I really can't divide x into 207. Once the degree here is lower than the degree of your divisor, then you're finished. And so we could write this as, remainder 207. Or if we wanted to write it in kind of a mixed expression form, we could say, well, the quotient is 2x squared plus 7x plus 39, and then there's the fractional part, which is 207 over x minus 5. And it's kind of a nice little exercise to kind of check the answer. Is if you multiply this by this, if you multiply these two things together and then add on the 207, you should get the original expression. Okay, so much like you do with numbers, you could check this by multiplying this times this, okay, and then add on the 207, and you should see the original value that you were dividing into. Okay, so that's long division for polynomials. And again, it's a little more involved than it is with numbers. You just kind of keep everything lined up pretty well, and you'll be okay. And try not to get yourself crossed up on the the pluses and minuses. It should be a pretty good process. But even this, okay, can be shortened. Okay, there's sort of a shorter version of this. This is kind of long division. Is there a short way to do this? And the answer is yes. And you may or may not have seen this in a previous class. And so let me slide it over here. We have what's called synthetic division. Okay, synthetic division, where basically we're going to use the same numbers as before. Instead, though, of writing when it's x minus 5, I'm just going to put a 5 right here. If this had been x plus 3 that I was using as my divisor, I would have used a negative 3 in that space right there. If this had been x plus 10, I would be using negative 10 right here. If this had been x minus 10, if I was dividing by x minus 10, well then I would be using just positive 10 in that space. So that's kind of the thought process there. And in time we'll kind of talk about why that is. But for right now, let's just kind of worry about the what. And then the other part here is I've got 2x cubed minus 3x squared plus 4x plus 12. And so I'm really dropping the variable portion. I'm just kind of bringing the coefficients down. 2, negative 3, 4, and 12. And these things all have place value. You have to keep in mind this means 12, this means 4x. In this position, it's negative 3x squared and 2x to the third. Okay, so this is all very synthetic. We're removing all the x's, all the variables in here. And the way it works is actually pretty slick. The first term, you just always drop down the first term, 2. And then you multiply. 2 times 5 is 10. 10 minus 3 is 7. So I just combine them. So 10 take away 3 is 7. And then I multiply again. 35, add on 4 to that. So 35 add on 4 is 39. 39 times 5, that's 154. That's 195 plus 12. 195 plus 12 is 207. And so if I wanted to read this, I would say, okay, this is my constant. This is x to the first. This is x to the second. So I believe the quotient is 2x squared plus 7x plus 39. And then the remaining part is 207 over, and then I was dividing by x minus 5, although I was doing it sort of symbolically or synthetically. And you'll notice this is the exact same answer that we got right here. And if you take a little time and look at this a little deeper, you'll kind of get a sense for what's going on here. These numbers, 2, 7, and 39, you kind of see them in throughout the process. And so you might be able to kind of connect pieces of these together. We're really just kind of omitting some of the steps in this process, and that's what makes this go a lot quicker. So that's called synthetic division. Okay, this is just regular, polynomial long division. This is the synthetic way, and this is the method we're going to use as we get through the next few days. Now, kind of an interesting little side note: if you were to plug 5, the number 5, into this expression, okay, we call this direct substitution. Okay? If you plugged 5 into this expression, you would end up getting the remaining term, as you did here. And this is what we call the remainder theorem, that dividing by x minus 5 is going to give you the same remainder, okay, as if you had taken the number 5 and did direct substitution. Another way of thinking about that is we often call this synthetic substitution. Synthetic substitution and direct substitution yield the same remainder. And this idea is called the remainder theorem. I know you had a few questions when you took that math test the other day. So that's it for division, and I'll pick up on my next video. Thanks for watching.